Welcome all of you to this video of Maths Made Easy. Now in this video we are going to take up pressure. Very important topic in ninth science, in ninth physics. Okay. Now what is pressure all about? We'll see in today's video what exactly is pressure. Okay. So pressure we talk about it regularly. When we talk about pressure we are always using this word. Okay. But then without understanding. Okay. So in physics how is pressure defined? We'll see it now. Okay, so pressure is actually pressure is the force or the thrust per unit area. Now what is this? Okay, now what is thrust per unit area? It is defined as the thrust per unit area. What is thrust? What is area? Okay, now if I have something, I have this duster. I keep this on the table. I keep it on a table. Okay, when I keep this on the table, then it has some weight. Okay, let it be a very heavy book and I keep it on the table. Now it has some weight. Okay, that weight it is exerting on the table below it. Now what happens if you have a table here and on top of it you have kept something heavy, you have kept a book, heavy book, or you have kept something heavy. Now what happens? It is exerting a force depending on how much weight it has. Okay, if the weight is more, the pressure on the table is more. If the weight is less, the pressure on the table is less. That all of you know. But then we cannot say that the weight of this body, we cannot say the weight of this body is equal to the pressure. That is wrong. Okay, so sometimes we say, okay, it is giving a pressure of 10 newtons on the table, which is wrong. Okay, if its weight is 10 newton, that doesn't mean the pressure is 10 newton. Let's see why. Now here, this body, this book or whatever has an area of contact, isn't it? It has one area of contact, that is if I take this duster, this is the area of contact. This much area is the area of contact when I keep like this. Okay, that is this area. Now, and what is thrust? Thrust is nothing but the weight of the body. Okay, so here is the weight of the body, this is the area. Now, what exactly they are trying to say? Thrust per unit area is pressure. Per unit area is pressure. Means the full weight is not the pressure. The full weight of the body is not the pressure. If the full weight is, let's say 100 Newton, we'll write it here. But the area per unit area. Now that can be per unit area means can be 1 centimeter square also, 1 meter square also. Okay, depending on the unit of this. If this is in Newton, this has to be in meter square because everything has to be SI. So here, now if the area of contact was, let's say 10, okay, I'm not mentioning the unit here, let's say it was 10, then for 1 centimeter square, how much was the force? Means 1 centimeter square was taking how much force of the whatever is kept on it, of the book, of the duster, whatever. So the force acting on 1 centimeter square or on 1 meter square, depending on the unit, is the pressure, okay, of the body. Okay, so not the full weight but the pressure acting on 1 centimeter square or 1 meter square. So here the pressure becomes 10. I'm not mentioning the unit here, okay, but after calculation it comes to a 10. Okay, now what are the units of pressure? Let's talk about the units of pressure. Here thrust is nothing but a weight or a force, which is, so any force, any thrust is a weight which we can write as Newton, and this is meter square. Okay, in SI I am talking about. Then it is Newton per meter square is one kind of unit, but then 1 Newton meter square is also called 1 Pascal. So this is called the SI unit of pressure. Okay, if we want, let's say we want it in CGS. Okay, so if we want in CGS, then we'll write pressure is, we'll write dyne here, isn't it? And we'll write centimeter square. Then dyne per centimeter square. Okay, There is no corresponding CGS unit like we have Pascal, we just say dyne per centimeter square. So that is how these are the units of pressure. So when we use Newton, we have to use meter square. When we use dyne, we have to use centimeter square. Mostly we use Newton only in our sums. Okay. Now there is something very interesting about this. I was talking about this one. Okay. I was talking about this. Now this, or let's take now this book. I have a book here. Now this book, if I keep on a table, okay, how much is the area of contact? This surface. This surface is the area of contact. Okay, so I am keeping it on the table. Area of contact is this much. Okay, if I keep on the table, if this is difficult to keep on the table, but supposing I can keep it on the table like this. Okay, what is the area of contact then? This becomes the area of contact. Okay, so you see the area of contact is changing depending on the same body I am keeping in different ways. Now I keep the this on the table like this. Okay, I keep it on the table like this. Okay, how much is the area of contact? This much is the area of contact. Whether this side or this side, it is this much. So I have two different, for the same weight of the body remains the same. But then there are three different areas of contact. One is this, one is this, and one is this. Okay, so three different areas of contact. Now what happens? The pressure keeps changing each time. When I keep it like this, pressure is different. When I keep it like this, pressure is different. When I keep it like this, pressure is different. Okay, so when I keep it like in the three, why is the pressure different? Let me see. Pressure, which is, this is thrust. Thrust is nothing but the weight of the body in this case, which is same. Okay, P1, that is maybe this, okay, this condition, okay, and by A1, okay. Then P2 can be the same thrust by A2, it can be this condition, okay. P3, okay, something which like a box will stand like this, okay, this book is not standing. Now thrust, it has to stand without a support, A3, now it can be this condition. Okay, now what happens? Now I know A1 is bigger than A2 and then A3. I know this. Okay, I can clearly see. Now when the same number you are dividing with a very big number, you get a small value. Then here's little bigger value and very small value, little smaller value and then very small value. What happens when you are dividing with a very small value? When you are dividing with a very small value, you get big answer, isn't it? I'll give one example. Let's say, now I'll give one example like 100, if that is the thrust, I divide with 50, big value, okay. Then 100 by, this is, let's take 20, and 100 by just a 5 maybe. So here it is 2, pressure is smallest here, okay, P1 is smallest, this is 5, little bigger pressure, and this is 20, which is the highest pressure. So smaller the area of contact, bigger is the pressure. That is why they tell that when you are, when parents will instruct, don't stand on the sofa, sit on the sofa. Okay, so naturally when you are sitting on the sofa, you are not giving so much of pressure because area of contact is more. Okay, but then, and they tell don't jump on the bed, because if you are jumping on the bed, okay, then also you are giving it a lot of pressure, because the area of contact is only the area of your 2 feet, the area of your feet. Okay, that is why the pressure is very high when you stand on the sofa or you stand on the bed. So it can damage the sofa, it can damage the bed because pressure is very high. On the other hand, when we lay on the bed, pressure is low because huge surface area of contact is so big. So there are lots of examples based on this, very interesting examples. Let's see. Why does a camel have broad feet? Okay, why does a camel have broad feet? One example I already talked about. Why I'm talking about these in detail is because they come as give reasons and you should know how to write the give reasons. Okay, why does a camel have broad feet? Camel have broad feet. Again, camel has to move in. A camel has to move in sand. Okay, so you also might have noted that when we walk on sand, when you have gone to beaches, when we walk on sand, you'll note that our feet sinks in, and every time we have to pull our feet out. Okay, it is difficult to walk in speed. We can't walk at that speed like we walk generally. Okay, so now these camels, they are always walking on feet and on sand, and they are supposed to walk very fast. The camels are called the ship of the desert. They walk very fast. Now, how do they walk so fast? Now, camel, if you see the structure of the camel, it is huge. Okay, so it has got a lot of weight. Now, if it has tiny feet, okay, like a horse or maybe a donkey or cows which have small feet, okay, so which have small feet, then they will sink into the sand and they will not be able to walk properly. Now, camel have broad feet because to increase the area of contact, you can say. Okay, so again the pressure, because of this thrust, this is the weight of the camel, here is the area of contact, the feet area. So now what happens is the camel is able to walk without the feet sinking in too much. So the feet does not sink in too much. Okay, so how do you write this answer? First you have to say yes, camel has a huge body weight. There are some keywords which give you answer marks. Okay, if you are writing 3 pages and still not writing the keyword, you will not get your marks. So here you have to say pressure to reduce the pressure. Okay, reduce pressure and to by increasing the surface area, the area of contact. Okay, by increasing the area of contact. This is the reduce pressure by increasing the area of contact is the answer to this. Why does a camel have broad feet? To reduce the pressure by increasing the area of contact is the keyword. So here reduce the pressure and increasing the area of contact so that it doesn't sink into the sand. So in each of these answers you have to keep writing all this. Okay, so let's see the next example. So remember, there are some uses of bigger surface area also, bigger area of contact. There are some uses of small area of contact also. Okay, why are the straps of school bags made wide? Okay, why are the straps of school bags made wide? What are the straps? The things that go above your shoulders. Now, if the straps are made very thin, now what will happen? The surface area with your area of contact with your shoulder will be less, and so lesser the area of contact, more the pressure. This is pressure is bigger. Okay, so now these days they manufacture these bags with nice cushiony belts over here, nice cushiony straps. That's really comfortable. So even if your bag is heavy, it doesn't cut into your shoulders. Okay, so that is why to reduce the pressure, here pressure is small. Okay, this is small pressure, this is a big pressure, because the area of contact is made bigger, and so the pressure exerted on the shoulder of the students, on the shoulder of the children is less. Okay, so they are more comfortable to carry. Okay, so you have to keep telling more the area of contact, lesser the pressure. Okay, lots of examples are there. Why are nails or needles made with very thin or thin what? Very thin. Why are nails and needles made very thin at the ends? Okay, so any needle you'll see or any nail, this side will be broad, that is to hammer it. But if you see, this end is made pointed like this. Okay, it's pointed. Same thing for a needle. You'll see this end will have place to put your, put the thread in. But here it will be very much pointed. What is the reason? It is made pointed so that to reduce, okay, it goes into if you hammer this, if it is not pointed, you'll have to give a lot of more force. For the same force, the pressure is increased, that is your capacity is limited. Okay, so when you are hitting it, let's assume that force is constant. But for the same force, if it is pointed here, it will give more pressure on the wall, it will go inside the wall easily. Here, same thing, for the same force given by the person who is doing the stitching, here it will go into the cloth easily. So actually, you have, if you have ever tried even even a blunt safety pin, okay, if you have tried putting it inside a cloth, it needs a lot of force, okay, it needs a lot of force to do that. So that is why to make things easy, it is made pointed. Now another thing is, why are knives made sharp? Okay, again for the same reason, knives are also made sharp, because if knives are not sharp, in fact you'll know that the sharper the knife is, the easier it is to cut with it. Okay, the blunter the knife is, more force you have to apply, and your hands will pain with a blunt knife, it will not pain with a sharp knife. So if you'll see these cooks cooking, no, very nicely, they just, okay, they just, you see how smoothly they cut. The reason is their knives are excellent. Okay, on the other hand, if you have a blunt knife, that means the edge is thick and the area of contact is more. Okay, area of contact is more, so you have to apply more force, because otherwise you have to give it more pressure. Okay, if the, so for the same force, it will cut the vegetables easily if it has a lesser surface area, because pressure is more. Okay, so these are few of the examples. Let's see more. Wide wooden sleepers are placed below tracks. Okay, below railway tracks. Okay. So what is wooden sleepers? Now you have seen it. Only thing is, so wooden sleepers are, you must have seen things like this, okay, and on this you have the railway lines. Yes, these are made out of wood. Yes, so whenever you have been on a train, you must have seen these. These are, and on this is the metallic, this is the metallic track of the train. Okay, so these are the wooden sleepers. Now these wooden sleepers are placed below tracks. Why? Wide wooden sleepers are placed below tracks. Why? Now these wooden sleepers are placed because these are metallic, and if you see the area of contact of these, it is very less. The area of contact of these are very less. Now what happens if it rains? Okay, if it rains, or supposing it okay, or supposing it is the soil is little wet, there is little bit of water logging, or whatever be the reason, or the soil is little soft, when the train goes over this will go down into the ground due to the pressure of the train. Okay, so now what can stop them from going into the ground are these wooden sleepers. So the actual pressure of the train is taken by these wooden sleepers. Now since these wooden sleepers are wide, they don't go into the ground so easily. Okay, so the train can run normally. Okay, so that's the reason we have to take these wooden sleepers. So that is again one use. Another, why are foundations of buildings made broader? Okay, now you all might not be knowing, but then if the building is like this, these days we have very tall towers. We have tall towers built everywhere. But remember, if the tower is tall, the foundation actually goes like this. Okay, you don't see it when it's being built. So actually, taller the tower, more they have to be careful about the foundation. Now, if with this much tall tower they give small foundation, then the pressure of the whole building, this with only this much of area of contact, it will not be able to take, and this can sink in. It can tilt also. Okay, so to keep it steady, the big foundation is made under the ground, which you can't see. Okay, you see only this much part, you see, okay, it is a 40-story apartment and all that, but you can't see this, which is they have worked they have made the foundation very broad to keep the building steady. So that was pressure, just an introduction. Okay, pressure is, there is a lot more in pressure. After this we shall be doing, in pressure we'll be taking up atmospheric pressure, we'll be taking up pressure in fluids, Okay, there'll be numericals. So one after the other I shall be posting the videos. So right after this we'll be taking up pressure in fluids, and then again few more give reasons will be there. Then atmospheric pressure, then also we have the we have Pascal's law. So there'll be one video exclusive for Pascal's law and its Pascal's law and the users of Pascal's law. Okay, so whoever has Pascal's law in your portion should go through that video. Okay, so that's it for today. If you have not subscribed the channel till now, please subscribe it. As I said, lots of more videos are going to come. Thanks all of you. Bye then.